Well, hi again, and congrats on getting through everything in episode 1. Seriously, that was a lot of work. So find a stranger and give them a high five. But then come back and let's get to work. Over the next hour, we're going to take things to the next level, aiming at some of the most difficult areas of symphony, like security, forms, and some serious doctrine topics. Some of this stuff will look pretty tough at first, but that's just because we're taking your symphony foo up to the next level. When you finish, you'll be another huge step towards mastering symphony. Okay, drink some coffee, stretch a little, and let's get to it. Symphony comes with a security component that's really powerful. Honestly, it's also really complex. It can connect with other authentication systems like Facebook or LDAP or load user information from anywhere, like a database or even across an API. The bummer is that hooking all this up can be tough, but since you'll know how each piece works, you'll be able to do amazing things. There's also some Jedi magic I'll show you later that makes custom authentication systems much easier. Security is 2 parts, authentication and authorization. Authentication checks the user's credentials. Its job is not to restrict access. It just wants to know who you are. Okay, so think of a building, or maybe even the Death Star. After the tractor beam forces you to land, you'll walk out and pass through a security checkpoint. Both stormtroopers and rebels check in here, prove who they are, and receive an access card, or a token in Symphony speak. Proving who you are and getting a token, that's authentication. The token can be used to unlock doors in this fully armed and operational battle station. Everyone inside has a token, but some grant more access than others. The second part of security, authorization, is like the lock that's on every door. It actually denies a user access to something. Authorization doesn't care if you're Obi-Wan or a stormtrooper. It only checks to see if the token you received has enough access to enter a specific room. Let's talk authentication first, which can be more complex than authorization. The security configuration lives entirely in the app-config security.yaml file, which is imported from the main config.yaml file. Security config lives in its own file because, well, it's kind of big and ugly. But there's no technical reason. You could move all of this into config.yaml and it would work just the same. Find the firewalls key. It's the most important part in this file. A firewall represents the authentication layer or security checkpoint for your app. Delete the login and dev firewall sections so that we just have one. Just like in a giant floating death machine, it makes sense for everyone to pass through the same security system that looks up people in the same corrupt imperial database. In fact, change the pattern key to be /. Now, every request that goes to our app will use this one firewall for authentication. Let's also change the login path key to be /my-login-url. Don't worry about what this is or what any of the other keys mean yet. They're just there to confuse you. I'll explain it all in a second. Now, uncomment the anonymous key. This lets anonymous users into the site, similar to letting a tourist enter the Death Star. We may want to require login for certain pages, or even maybe nearly every page. But we're not going to do that here. Remember, the firewall is all about finding out who you are, not denying access. Head back to the browser, but don't refresh. First, notice the little red icon on your web debug toolbar. When you hover over it, it says, "You are not authenticated." Now refresh. Yes, it's green and says Anon. Clicking it shows us that we're now authenticated. Yeah, it's a bit odd, but anonymous users are actually authenticated since they pass through our firewall. But don't panic. It's easy in code to check if the user is actually logged in or not. I'll show you that later. Of course, we haven't actually done the work to make it possible to log in yet, but we'll get to those silly details in a second. Before we keep going with authentication and make it possible to log in, let's try out our first piece of authorization and start denying access. Head back to security.yaml. The easiest way to deny access is via the access control section. Let's use its regular expression coolness to protect any URLs that start with /new or /create. Roles are given to a user when they log in, and if you're not logged in, you don't have any. Here, we're saying that you at least need role user to access these URLs. Try it out. When we try to add an event, we're redirected to /my-login-URL. Hey, I know that URL. That's what we put for the login path config key. So here's the magic that just happened behind the scenes. 1. We tried to go to /new. Since our anonymous user doesn't have any roles, the access controls kicked us out. And 2, the firewall saves the day. Instead of giving us an access denied screen, it decides to give us a chance to log in. The form login key tells the firewall that we want to use a good old-fashioned login form, and that the login form should live at /my-login-URL. It's our job to actually create the login page, and since we haven't yet, we see the big ugly 404 error. The access control has a few more tricks to it. Head over to the security chapter of the book and find the section on access control. I want you to read this, but the most important thing to know is that only one access control entry is matched on a request. Symfony goes down the list, finds the first match, and uses only it to check authorization. I'll show you an example during the last chapter. There's also other goodies, like different access controls based on the user's IP address or depending on which hostname is being accessed. You can even make it so that a user is redirected to HTTPS. So where's the actual login form? Well, that's our job. The security layer just helps us by redirecting the user here. Oh, and there's a really popular open source bundle called FOS User Bundle that gives you a lot of what we're about to build. The good news is that after building a login system in this tutorial, you'll better understand how it works. So build it once here, then take a serious look at FOS User Bundle. Let's create a brand new shiny bundle called User Bundle for all of our user and security stuff. We could use the App Console Generate Bundle task to create this, but let's do it by hand. Seriously, it's easy. Just create a user bundle directory and an empty user bundle class inside of it. A bundle is nothing more than a directory with a bundle class. Now just activate it in the app kernel class and voila! Our brand new shiny bundle is ready. To make the login page, add a controller directory and put a new security controller class inside of it. Give the class a login action method. This will render our login form. Before we fill in the guts of login action, we need a route. After watching episode 1, you probably expect me to create a routing.yaml file in user bundle and add a route there. Ha! I am not so predictable. Instead, we're going to get crazy and build our routes right inside the controller class, using annotations. The docs for this feature live at symfony.com under a bundle called Sensio Framework Extra Bundle. This bundle came pre-installed in our project. How thoughtful! First, add the route annotation namespace. Now we can add the route right above the method. Finally, tell Symfony to look for routes in our controller by adding an import to the main routing.yaml file. Remember that Symfony never automatically finds routing files. We always import them manually from here. Cool! Change the URL in your browser to /login. This big ugly error about our controller not returning a response is great news. No, seriously, it means the route is working. Now let's fill in the controller. Most of the login page code is pretty boilerplate, so let's use the age-old art of copy and paste from the docs. Head to the security chapter and find the login form section. Copy the login action and paste it into our controller. Don't forget to add the use statements for the security context interface and request classes. The method just renders a login template. It doesn't handle the submit or check to see if the username and password are correct. Another layer handles that. It does pass the login error message to the template if there is one, but that's it. The pasted code is rendering a template using our favorite render method that lives in Symfony's base controller. Let's not do this. Instead, let's use another shortcut, the @template annotation, which is also from Sensio Framework Extra Bundle. Anytime we use an annotation in a class for the first time, we'll need to add a use statement for it. Copy this from the docs. Now put @template above the method and just return the array of variables you want to pass to Twig. With @template, Symfony renders a template automatically and passes the variables we're returning into it. It's cool, saves us some typing, and supports the rebel forces. Okay, we're almost done. Seriously. Copy the template code from the docs and create the login.html.twig file. This prints the login error message if there is one and has a form with username and password fields. When we submit, Symfony is going to be looking for these fields, so their names are important. Let's make this extend our base.html.twig template. I'll also add a little bit of extra markup. Route check. Controller check. Template check. Let's try it. Oh boy, an error. The copied template code has a form that submits to a route called login check. Let's create another action method and use @route to create that route. Call me crazy, but I'm going to leave this action method completely blank. Normally, it means that if you went to /login_check, it would execute this controller and cause an error since we're not returning anything. But this controller will never be executed. Before I show you, open up security.yaml and look at the form login configuration. Login_path is the URL or route name that the user should be sent to when they hit a secured page. Change this to be login_form, the name of our login action route. Check path is the URL or route name that the login form will be submitted to. Change this to be login_check. In your browser, try going to /new. Yes! Now we're redirected to /login. Thanks to the login_path config key. The page looks just terrible, but it's working. Now let me show you one of the strangest parts of Symfony's security system. When we log in using user and user pass, it works. We can see our username in the web debug toolbar and even a role assigned to us. What the heck just happened? When we submit, Symfony's security system intercepts the request and processes the login information. This works as long as we post username and password to the URL /login_check. This URL is special because its route is configured as the check path in security.yaml. The login check action method is never executed because Symfony intercepts post requests to that URL. If the login is successful, the user is redirected to the page they last visited or the home page. If login fails, the user is sent back to /login and an error is shown. And where did the user and user pass stuff come from? Actually, right now the users are just being loaded directly from security.yaml. In a minute, we'll load users from the database instead. What about logging out? Symfony has some magic for that too. Look at the logout part of security.yaml. Path is the name of your logout route. Set it to logout. We'll create that route in a second. Target is where you want to redirect the user after logging out. We already have a route called event, which is our event list page. Use that for target. To make the logout route, let's add another method inside security controller and use the @route annotation. Just like with the login check action, the code here won't actually get hit. Instead, Symfony intercepts the request and processes the logout for us. Try it out by going to /logout manually. Great! As you can see by the web debug toolbar, we're anonymous once again. If we fail login, we see a bad credentials message. When Symfony handles the login, it saves this error to the session under a special key, and we're just fetching it out in login action. Actually, we have more code than we need here. Remove the if statement and just leave the second part. The first part isn't used unless you reconfigure how Symfony sends you to the login page. I know, the login page is embarrassing looking. So I made a login.css file to fix things. Find it in the Resources Episode 2 directory on the code download. Let's move it into a Resources Public CSS directory in the user bundle. Just like in Episode 1, run app console assets install and add the --symlink option, unless you're on Windows. This creates a symbolic link from Web Bundle's user to the Resources Public directory in the user bundle. Since Web is our application's document root, this makes our new CSS file accessible in a browser by going to Bundles, User, CSS, login.css. So how can we add the CSS file to only this page? First, open up the base template. Here we have a bunch of blocks, including one called Style Sheets. All of our global CSS link tags live inside of it. Let's override this block in login.html.twig and add the new link tag to login.css. Cool! But do you see the problem? This would entirely replace the block, but we want to add to it. The trick is in the twig parent function. By including this, all the parent block's content is included first. Refresh now. Much less embarrassing looking. When you need to add CSS or JS to just one page, this is how you do it. And by adding a little error class, it looks even better. And while we're making things look nicer, let's open up base.html.twig and add a link tag to the Bootstrap CSS file. Just use a CDN URL for simplicity. Back in the login.html.twig, I'll tweak the submit button so things look nicer. Refresh. Much better. I'm a programmer, but I don't want the site to look totally awful. While we're here, let's change the bad credentials message. It's a little programmery. The message comes from deep inside Symfony, so to customize it, we'll use the translator. First, use the twig trans filter on the message. Next, create a translation file in app resources translations messages.en.yaml. This file is just a simple key-value pair of translations. Now we just need to activate the translation engine in app.config.yaml. Okay, now try it. Again, so much better. Since logging out works, let's add a link to actually do it. We already know logging out in Symfony is really easy. As long as the logout key is present under our firewall and we have a route to /logout, we can surf there and it'll just work. Symfony takes care of the details behind the scenes. Open up the homepage template and add the logout link. This is just like generating any other URL. Use the twig path function and pass it the name of the route. It works, of course, but we don't want to show it unless the user is actually logged in. To test for this, use the twig isGranted function and pass it a special isAuthenticated_remembered string. And that works perfectly. IsGranted is how you check security in Twig. And we also could have passed normal roles here, like role user and role admin, instead of this isAuthenticated_remembered thingy. So in addition to checking to see if the user has a given role, Symfony has 3 other special security checks you can use. First, isAuthenticated_remembered is given to all users who are logged in. They may have actually logged in during the session or may be logged in because they have a Remember Me cookie. Second, isAuthenticated_fully is actually stronger. You only have this if you've actually logged in during this session. If you're logged in because of a Remember Me cookie, you won't have this. Finally, isAuthenticated_anonymously is given to all users, even if you're not logged in. And since literally everyone has this, it seems worthless. But it actually does have a use if you need to whitelist URLs that should be public. I'll show you an example in the last chapter. Since we're checking for isAuthenticated_remembered, we're showing the logout link to anyone who is logged in, via a Remember Me cookie or because they recently entered their password. We want to let both types of users log out. Let's get super fancy and add a login link for those anonymous souls. You'll probably want to use isAuthenticated_remembered almost everywhere, and save isAuthenticated_fully for pages that need to be really secure, like checkout. If the user is only isAuthenticated_remembered and hits one of those pages, they'll be redirected to log in. Let's log in as user again and surf to /new. Since we have the role user role, we're allowed access. In the access control section of security.yaml, change the role for this page to be role admin and refresh. This is the access denied page. It means that we are authenticated but don't have access. Of course, in Symfony's prod environment, we'll be able to customize how this looks. We'll cover how to customize error pages in the next episode. The access control section of security.yaml is the easiest way to control access, but also the least flexible. Change the access control entry back to use role user, and then comment both of them out. We're going to deny access from inside our controller class instead. Find the new action in Event Controller. To check if the current user has a role, we need to get the security context. This is a scary sounding object, which has just one easy method on it, isGranted. Use it to ask if the user has the role admin role. If the user doesn't have role admin, we need to throw a very special exception called access denied exception. Add a use statement for this class and then throw a new instance inside the if block. If you add a message, only the developers will see it. In Symfony 2.5 and higher, there's even a shortcut, Create Access Denied Exception method. When we refresh now, we see the access denied page. But if we were logged in as an admin who does have this role, we'd see the page just fine. Normally, if you throw an exception, it'll turn into a 500 page. But the access denied exception is special. First, if we're not already logged in, throwing this causes us to be redirected to the login page. But if we are logged in, we'll be shown the access denied 403 page. We don't have to worry about whether the user is logged in or not here. We can just throw this exception. Phew, security is hard. But wow, you seriously know almost everything you'll need to know. You'll only need to worry about the really hard stuff if you need to create a custom authentication system. Like if you're authenticating users via an API key instead of a login form. If you're in this situation, make sure you read the Symfony cookbook entry called How to Authenticate Users with API Keys. It uses a feature that's new to Symfony 2.4, so you may not see it mentioned in older blog posts. Okay, let's unbreak our site. To keep things short, create a new private function in the controller called Enforce User Security. And copy our security check into this. Now use this in New Action, Create Action, Edit Action, Update Action, and Delete Action. You can see how sometimes using access control can be simpler, even if this method is more flexible. Choose whichever works the best for you in each situation. Repeat after me. We're really great. And our security system is almost as cool as we are. So let's keep up the pace and load users from the database instead of the list in security.yaml. What we're about to do is similar to what the awesome open source FOS user bundle gives you. We're going to build this all ourselves so that we really understand how things work. Later, if you do use FOS user bundle, you'll be a lot more dangerous with it. Okay, forget about security. Seriously. Just think about the fact that we want to store some user information in the database. To do this, we'll need a user entity class. That sounds like a lot of work. So let's just use the doctrine generate entity app console command. For the entity shortcut name, use user bundle :user. Remember, Doctrine uses this shortcut syntax for entities. Give the class just two fields, username as a string and password as a string. And of course, choose Yes to generating the repository class. I'll explain why these are so fabulous in a second. Once the robots are done writing the code for us, we should have a new user class in the entity directory of user bundle. Let's change the table name to be Yoda_user. Right now, this is just a plain, regular Doctrine entity that has nothing to do with security. But our goal is to load users from this table on login. The first step is to make your class implement a user interface. This interface requires us to have 5 methods. And hey, we already have 2 of them, getUsername and getPassword. Cool, so let's add the other 3. First, getRoles returns an array of roles that the user should get. For now, we'll hardcode a single role, roleUser. Second, add erase credentials. Keep this method blank for now. We'll add some logic to this later. And finally, add getSalt. And just make it return null. I'll talk more about this method in a second. Now that the user class implements user interface, Symfony's authentication system will be able to use it. But before we hook that up, let's add the Yoda user table to the database, by running the doctrine schema update command. And for the grand finale, let's tell the security system to use our entity class. In security.yaml, replace the encoder entry with our user class and set its value to bcrypt. This tells Symfony that the password field on our user will be encoded using the bcrypt algorithm. The one catch is that bcrypt isn't supported until PHP 5.5. So if you're using PHP 5.4 or lower, you'll need to install an extra library via Composer. No problem. Head to your terminal and use the Composer require command and pass it ircmaxl/password-compat. When it asks, use the ~1.0.3 version. By the way, this require command is just a shortcut that updates our composer.json and then runs the Composer update. Now for the Jedi magic. In security.yaml, remove the single provider's entry and replace it with a new one. I'm just inventing the our_database_users part. That can be anything. But the entity key is a special built-in provider that knows how to load users via a doctrine entity. Yeah, and that's really it. Okay, let's try it. When you refresh, you may get an error. Don't panic, this is just because we're still logged in as one of the hard-coded users, even though we just deleted them from security.yaml. It's a one-time error, just refresh and it'll go away. Now that the error is gone, try logging in. Wait, but our user table is empty. So we can see the bad password message, but we can't actually log in yet. But we're pros, so it's no problem. Let's copy the load events fixtures class into the user bundle. Rename it to load users and update the namespaces. Saving users is almost easy. Just create the object, give it a username, and then persist and flush it. The tricky part is that darn password field, which needs to be encoded with bcrypt. But what's cool is that Symfony gives us an object that can do all that encoding for us. To get it, first make the fixture implement the container-aware interface. This requires one new method, setContainer. In it, we'll store the container variable onto a new container property. Because we implement this interface, Symfony calls this method and passes us the container object before calling load. Remember that the container is the array-like object that holds all the useful objects in the system. We can see a list of those objects by running the container debug console task. Let's create a helper function called encodePassword to, encode the password. This step may look strange, but stay with me. First, we ask Symfony for a special encoder object that knows how to encrypt our passwords. Remember the bcrypt config we put in security.yaml? Yep, this object will use that. After we grab the encoder, we just call encodePassword, grab a sandwich, and let it do all the work. Behind the scenes, it takes the plain text password, generates a random salt, then encrypts the whole thing using bcrypt. Okay, so let's set this onto the password property. Try it. Reload the fixtures from the command line. Let's use the query console task to see what the user looks like. Nice! We can see the encoded password, which for bcrypt also includes the randomly generated salt. You do need to store the salt for each user, but with bcrypt, it happens automatically. Symfony requires us to have a getSalt function on our user, but it's totally not needed with bcrypt. Back at the browser, we can log in. Behind the scenes, here's basically what's happening. 1. A user entity is loaded from the database for the given username. 2. The plain text password we entered is encoded with bcrypt. And 3. The encoded version of the submitted password is compared with the save password field. If they match, then you now have access to roam about this fully armed and operational battle station. Right now, all users get just one role, role user, because it's what we're returning from the getRoles function inside the user entity. Add a roles field and make it a JSON array type. JSON array allows us to store an array of strings in one field. In the database, these are stored as a JSON string. Doctrine takes care of converting back and forth between the array and JSON. Now just update the getRoles method to use this property and add a setRoles method. Cool! Except the way it's written now, a user could actually have 0 roles. Don't let this happen. That user will become the undead and cause a zombie uprising. They can log in, but they won't actually be authenticated. Be a hero by adding some logic to getRoles. Let's just guarantee that every user has role user. Update the SQL for the new field and then head back to the fixture file. Let's copy the code here and make a second Wayne admin user. Give this powerful Imperial user role admin. Let's reload the fixtures. Now, when we log in as Wayne admin, the web debug toolbar shows us that we have role user and role admin. Cool! Could we disable users, like if they were spamming our site? Well, we could just delete them and send them a strongly worded email. But yeah, we can also disable them. Add an isActive Boolean field to user. If the field is false, it will prevent that user from authenticating. Don't forget to add the getter and setter methods either by using a tool in your IDE or by rerunning the doctrine generate entities command. After that, update the schema to add the new field. So the isActive field exists, but it's not actually used during login. To make this work, change the user class to implement advanced user interface instead of user interface. The new interface is a stronger version of user interface that requires 4 additional methods. I'll use my IDE to generate these. If any of these methods return false, Symfony will block the user from logging in. To prove this, let's make them all return true, except for isAccountNonLocked. Logging in now is less fun. We're blocked with a helpful message. Each of these methods does the exact same thing. They block login. Each will give the user a different message, which you can translate if you want. Set each to return true except for isEnabled. Let's have it return the value for our isActive property. If isActive is false, this should prevent the user from logging in. Head over to our user fixtures so we can try this. Set the Wayne admin user to inactive. Next, reload your fixtures. When we try to log in, we're automatically blocked. Cool. Let's remove the setIsActive call we just added and reload the fixtures to put everything back where it started. Now let's have our users provide an email and let them log in using it or their username. Let's start like we always do, by adding the property to our user class with some doctrine annotations. Next, generate or write a getter and a setter for the new property. As a reminder, I'll use the doctrine generate entities command to do this. That little -- no backup prevents the command from creating a little backup version of the file. You're using version control, so we don't need to be overly cautious. You are using version control, right? Next, update the database schema to add the new field. Finally, update the fixtures so that each user has an email. Reload everything to refresh the database. When a user logs in right now, the security system queries for it using the username field. That's because we told it to in our security.yaml configuration. We could change it here to be email instead, but there's no way to say email or username. We can make this more flexible, but first we need to learn about doctrine repositories. Find an open user repository. This is a doctrine repository, and it was generated for us. Every entity has its own repository class, and it knows that this is the repository class for user because of an annotation on that class. Repositories are where query logic should live. We could create methods like findActiveUsers, which would query the database for users that have a value of 1 for the isActive field. And actually, we've already begun using repositories in our project. Open up Event Controller and check out the indexAction method. To query for events, we call getRepository on the Entity Manager. The getRepository method actually returns an instance of our very own event repository, but when we open up that class, it's empty. So where does the findAll method live? The answer is Doctrine's base entity repository class, which we're extending. If we open it, you'll find some of the helpful methods that we talked about in the previous screencast, including findAll. So every repository class comes with a few helpful methods to begin with. To prove that getRepository returns our event repository, let's override the findAll method and just die to see if our code is triggered. And when we go to the events page, our page gives us an epic cry. Now open up the event entity. Above the class, you'll see an @ORM entity annotation. Aha! The repository class is what's telling Doctrine to use event repository. Let's remove that part and see what happens. When we refresh, there's no epic cry. In fact, everything works perfectly. We didn't tell Doctrine about our custom repository, so when we call getRepository in the controller, it just gives us an instance of the base entity repository class. That was nice. Our overridden findAll method is bypassed and the real one is used. Let's undo our damage by re-adding the repository class option and remove the dummy findAll method. So every entity has its own repository with helpful methods like findAll for returning objects of that type. And when those shortcut methods won't work, we'll add our own methods. All of our query logic should live inside repositories. It'll make your life much more organized later. What if we wanted to find a user by matching on the email or username columns? We would, of course, add a findOneByUsername or email method to user repository. To make queries, you can use an SQL-like syntax called DQL, the Doctrine Query Language. You can even use native SQL queries if you're doing something really complex. But most of the time, I recommend using the awesome Query Builder object. To get one, call Create Query Builder and pass it an alias. Now add the where clause with our OR logic. The Query Builder has every method you'd expect, like left join, order by, and group by. It's really handy. The stuff inside and where looks similar to SQL, except that we use placeholders for the two variables. Fill each of these in by calling setParameter. The reason this is separated into two steps is to avoid SQL injection attacks, which are really no fun. To finish the query, call getQuery and then get1 or null result, which, as the name sounds, will return the user object if it's found or null if it's not found. To try this out, let's temporarily use the event controller's index action. Get the user repository by calling getRepository on the entity manager. Remember, the argument you pass to getRepository is the entity's shortcut name, the bundle name followed by the entity name. Now that we have the user repository, let's try our new method and dump the result. When we refresh, we see the user. If we try the email instead, we get the same result. Now let's get rid of these debug lines. I'm trying to get a working project going here, people. But this is a really common pattern we'll see more of. Use the repository in a controller to fetch objects from the database. If you need a special query, just add a new method to your repository and use it. Hey there, repository expert! So our actual goal was to let the user log in using a username or email. If we could get the security system to use our shiny new find one by username or email method to look up users at login, we'd be done. And back to our real job of crushing the rebel forces. Open up security.yaml and remove the property key from our entity provider. Try logging in now. Ah, a great error. Without the property, Doctrine has no idea how to look up the user. Instead, it tries to call a method on our user repository. But for that to work, our user repository class must implement user provider interface. So let's open up user repository and make this happen. As always, don't forget your use statement. This interface requires three methods: refresh user, supports class, and load user by username. I'll just paste these in. The really important method is load user by username, because Symfony calls it when you log in to get the user object for the given username. So we can use any logic we want to find or not find a user, like never returning users named Jar Jar Binks. We can just reuse the find one by username or email method we created earlier. If no user is found, the method should throw a special username not found exception. Try logging in again using the email address. It works! Behind the scenes, Symfony calls the load user by username method and passes in the username we submitted. We return the right user object, and then the authentication just keeps going like normal. We don't have to worry about checking the password because Symfony still does that for us. Okay, enough about security and doctrine. But give yourself a high five because you just learned some of the most powerful but difficult stuff when using Symfony and doctrine. You now have an elegant form login system that loads users from the database and that gives you a lot of control over exactly how those users are loaded. Now for a registration page. There's a problem. I have to bother you quickly with a little issue of serialization. When a user logs in, the user entity is stored in the session. For this to work, PHP serializes the user object to a string at the end of the request and stores it. At the beginning of the request, the string is unserialized and turned back into the user object. This is great, and it's obviously working great. We're surfing around as Wayne the admin, but there's a gotcha in Doctrine. Sometimes Doctrine will stick some extra information onto our entity, like the entity manager, that big important object we use to save things. Normally we don't care about this, but when the user object is serialized, having that big object hidden in our entity causes serialization to fail. The entity manager contains a database connection and other information that just can't be serialized. We need to help Doctrine out. Start by adding the serializable interface to the user class. This core PHP interface has two methods: serialize and unserialize. When the user object is serialized, it'll call the serialize method instead of trying to do it automatically. When the string is deserialized, the unserialize method is called. This may seem odd, but let's just return the ID, username, and password inside an array for serialize. For unserialize, just put those three values back on the object. If you think about it, this should kind of break everything. When Symfony gets the user object from the session and deserializes it, our user will have lost some of its data, like roles and is active. That's not cool. Clearly that's not the case. Symfony's security system is smart enough to take the ID and query for a full, fresh copy of the user object on each request. We can see this right in the web debug toolbar. Once a user is logged in, each request has a query that grabs the current user from the database. So we're good. Let's make our site a little bit more legit with the registration form. Go grab some coffee, 'cause we're about to rock our world with some big and powerful concepts, like forms and validation. Let's start by creating a new register controller class and user bundle. Creating a controller by hand is easy. Just add the right namespace and then extend Symfony's base controller class. The register action method will be our actual registration page. I'm kind of liking these annotation routes, so let's use those again. Remember, to do this, we need two things. First, add the route use statement, and then set up the route above the method. Second, we need to import the routes and routing.yaml. And hey, we're already importing annotations from the entire controller directory, so we're ready to go. To see if the route is being loaded, run the router debug console task. Yep, there it is. Now let's build a form, which is an object that knows all of the fields we want and their types. It'll help us render the form and process its values. It's pretty fancy. Start by calling the createFormBuilder method. Now use the add function to give the form username, email, and password fields. The two arguments to add are the name of the field and the field type. Symfony comes with built-in types for creating text fields, select fields, date fields, and force fields. I'll show you where to find a list in a minute. When we're all done, we call getForm. I want to render the form, so let's pass it to Twig. To save and impress my Ewok friends, I'm going to use the @template annotation trick. Pass the form as the only variable. So let's create the twig template. Make a registered directory in Resources Views, since we're registering from Register Controller. And @template uses that to figure out the template path. I'll paste in some HTML goodness to get us started. So let's head to the browser and see how things look so far. When we go to /register, we see a nice looking page. Kidding! We see a huge, horrible, threatening error. Look closely. The error contains the answer. I've used the @template shortcut but forgot to put a use statement for it. After adding the namespace, I can refresh and see the page. Create an HTML form tag that submits right back to the same route and controller we just created. The easiest way to render a form is all at once by using a special form widget twig function. Give it the form variable that we passed into the template, and add a submit button. Refresh the page. Whoa, man, another error. This one is more difficult to track down, but it does have one important detail. Specifically, argument 1 passed to form renderer, search and render block must be an instance of form view, instance of form given. That's a lot of words, but it means that somewhere we're calling a method and passing it the wrong type of object. It's expecting a form view, but we're passing it a form. Something is wrong with the form we created. Head back to Register Controller to fix this. Whenever you pass a form to a template, you must call createView on it. This transforms the object from a form into a form view. This isn't important, just remember to do it. The error is a bit tough, but now you know it. Refresh now and celebrate. We have a fully operational and rendered form. Actually, we haven't written any code to handle the form submit. That'll come in a minute. There's an even easier way to render the form, and while I don't love it, I want you to see it. Head to the Forms chapter of the docs. Under the Rendering the Form section, it renders with just one line. This displays the fields, the HTML form tag, and even a submit button, if you configure one. If you scroll up, you'll see that the form has a save field that's a submit type. I'm happy rendering the HTML form tags and the submit buttons myself, but you will see this rendering syntax, and I don't want you to be confused. It's all basically doing the same thing. In reality, rendering the form all at once probably won't be flexible enough in most cases. To render each field individually, use the form row function on each of your fields. Refresh the page and inspect the form. Each field row is surrounded by a div and contains the label and input. In the next screencast, we'll learn how to customize how a field row is rendered. But even now, we can take more control by using the form label, form widget, and form errors functions individually. Let's try it on just the username field. Form row just renders these 3 parts automatically, so this is basically the same as before. I usually try to use form row whenever possible, so let's change the username back to use this. Apart from fields themselves, there are 2 other things that should be in every form. First, make sure you call form errors on the entire form object. Most errors appear next to the field they belong to, but in some cases, you might have a global error that doesn't apply to any one specific field. It's not common, but this takes care of rendering those. Next, add form rest. It renders any fields that you forgot. In addition to that, Form rest is really handy because it renders any hidden fields automatically. All forms have a hidden token field by default to protect against CSRF attacks. With form rest, you never have to worry or think about hidden fields. We talk more about these functions in future episodes, but under the reference section of Symfony's documentation, there's a page called Twig Template Form Function and Variable Reference. That mentions all of these functions and how to use them. We have just one password box, so let's turn this into 2 boxes by using the repeated field type. Let's also change the email field to be an email type. The repeated field type is special because it actually renders 2 fields. In this case, password fields. If the 2 values don't match, a validation error will show up. If you refresh, you'll see the 2 fields. Oh no, attack of the clones! The email field looks the same, but if you inspect it, you'll see that it's an input email field, an HTML5 field type that should be used. Head over to Symfony's documentation and go into the reference section. There, you'll find a page called Form Field Type Reference. This is awesome! It shows you all of the built-in field types and the options you can pass to each. For example, if you click Repeated, it shows you how to customize the error message that shows up if the fields don't match and some other stuff. Use this section to your advantage. Now look back at our 2 password fields. This highlights a very special aspect about the way forms work. Specifically, a single field may in fact be one or many fields. When you use the repeated field type, it creates 2 subfields called first and second. To see what I'm talking about, replace the form row that renders the password field with 2 lines, one that renders the first box and one that renders the second. When we refresh, we see exactly the same thing. I just wanted to highlight how password is really now 2 fields. And we can render them individually or both at once. If this feels confusing, don't worry. This concept is a little bit more advanced. Since first and second are, well, terrible labels, let's change them. One way to do this is by adding a second argument to form row and passing a label key. Refresh. Much better. Okay, let's get this form to actually submit. Since we're submitting back to the same route and controller, we want to process things only if the request is a post. First, we'll need Symfony's request object. To get this in a controller, add a request argument that's type hinted with Symfony's request class. Normally, if you have an argument here, Symfony tries to populate it with a routing wildcard with the same name as the variable. If it doesn't find one, it throws a giant error. The only exception to that rule is this. If you type hint an argument with the request class, Symfony will give you that object. This doesn't work for everything, only the request class. Use the form's handleRequest method to actually process the data. Next, add an if statement that checks to see if the form was submitted and if all the data is valid. The handleRequest method grabs the posted data from the request, processes it, and runs any validation. And actually, it only does this for post requests, so on a GET request, form is submitted returns false. If the form is submitted because it's a post request and passes validation, let's print the submitted data for now. If the form is invalid, or if this is a GET request, it'll just skip this block and re-render the form with errors if there are any. Time to test it. We haven't added validation yet, but the password fields have built-in validation if the values don't match. When I submit, the form is rendered, meaning there was an error. In fact, there is now a little red box on the Web Debug toolbar. If we click it, we can see details about the form, what was submitted, and options for each field. Head back and fill in the form correctly. Now we see our dump data. Notice that the data is an array with a key and value for each field. Let's take this data and build a new user object from it. There is an easier way to do this, and I'll show you that in a second. We still need to encode and set the password. For now, let's copy in some code from our user fixtures to help with this. We'll make this much more awesome in the next screencast. Use this function, then finally persist and flush the new user. The last step of any successful form submit is to redirect. We'll redirect to the home page. First, we need to generate a URL, just like we do with the path function in Twig. In a controller, there's a generate URL function that works exactly the same way. To redirect, use the redirect function and pass it the URL. Remember that a controller always returns a response object. Redirect is just a shortcut to create a response that's all set up to redirect to this URL. Okay, time to kick this proton torpedo. As expected, we end up on the home page. We can even log in as the new user. Head back to the controller and remove the isSubmitted call in the if statement. This actually doesn't change anything because isValid automatically returns false if the form wasn't submitted, meaning if the request isn't a post. So either just do this or keep the isSubmitted part in there if you want. I find it adds some clarity. Now what if we wanted some default data to appear on the form? Well, we can just pass the data as the first argument to create Form Builder. Refresh and check that out. When we submit, Form Get Data gives us an associative array. That's cool, but what if it actually built the user object for us? Remove the default data we just added and pass a second argument to create Form Builder. This is an array of options for the form, and we'll pass it a data class key that's set to our user class. Let's dump the form values again and give it a try. Cool! Instead of an associative array, we get back a full user object populated with the form data. Behind the scenes, the form creates a new user object and then calls setUsername, setEmail, and setPassword on it, passing each the value from the form. Now we can simplify things on our controller. So how can we set default data on the form now? Put back the array we had earlier. Refresh and look at the error message closely. It's telling us that we gave the form an array, but it was expecting a user object. The data class option tells the form that both the output and the input of the form should be a user. So to set default data, just create a user object, give it some data, and pass it in. Refresh now. It looks great. We're abusing our password field. It temporarily stores the plain text submitted password and then later stores the encoded version. This is a bad idea. What if we forget to encode a user's password? The plain text password would be saved to the database instead of throwing an error. And storing plain text passwords is definitely against the Jedi code. Instead, create a new property on the user entity called plain password. Let's also add the getter and setter method for it. This property is just like the others, except that it's not actually persisted to the database. It exists just as a temporary place to store data. Find the erase credentials method and clear out the plain password field. This method isn't really important, but it's called during the authentication process, and its purpose is to make sure your user doesn't have any sensitive data on it. Now update the form code, changing the field name from password to plain password. Also, don't forget to update the template. Now when the form submits, the plain password is populated on the user. Use it to set the real encoded password property. Let's try it out. I'll register as a new user and then try to log in. Once again, things are working perfectly. We build our form right inside the controller, which was really simple. But it makes our controller a bit ugly, and if we needed to reuse this form somewhere else, that wouldn't be possible. For those reasons, the code to create a form usually lives in its own class. Create a new form directory and a new file called register form type. Create the class, give it a namespace, and make it extend a class called abstract type. We need to add a few methods to this class. The first and least important is getName. Add this and just return a string that's unique among your forms. It's used as part of the name attribute on your rendered form. The really important method is buildForm. I'm going to use my IDE to create this method for me. If you create yours manually, just don't forget the use statement for the form builder interface. The buildForm method is where we build our form. Genius! Copy the code from our controller that adds the fields and put that here. Finally, create a setDefaultOptions function and set the data class option to it. That's it! This class is now a recipe for exactly how the form should look. Remove the builder code in our controller. Instead, replace it with a call to create form and pass it an instance of the new register form type. Refresh. We've conquered forms. Some quick review. A form is something you build, giving it the fields and field types you need. At first, a form just returns an associative array, but we can change that with the data class option to return a populated object. Forms can also be built right inside the controller or in an external class. Got it? Great! Let's move on to validation. Let's add some validation. What if I don't enter a valid email address, or I choose a username that's already taken? Right now, the form would submit just fine, which is lame. Try to submit a blank form right now. Whoa! We do have some validation. In fact, if I enter an invalid email address, we see another error. This is HTML5 validation. When I inspect a field, we see what's triggering it. First, each field has a required attribute, which tells an HTML5 compliant browser to throw an error if the field is left blank. Second, the input type equals email field tells the browser to expect a valid email address instead of any string. We got an input type equals email field because we're using the emailed field type in our form. But where are these required attributes coming from? To answer that, look at the third argument when adding a field, the options array. Every field type can be configured in different ways. For example, the repeated field has a type option. There are also a bunch of options that every field has, required being one of them. Set the required option on email to false and refresh. When we inspect, we see that the required attribute is gone. All fields have this option, and it's important to realize that it defaults to true. There are a lot more options available for each field type. The easiest way to learn about them is via the documentation. Remember the form field type reference page we saw earlier? Yep, it shows you all the field types and all of their options. You can also dig into the source code to find out what options are available. For the repeated type, there's a class called, well, repeated type. The set default options method shows you the options that are special to this type. Most of the global options are inherited from a class called form type. In here, you can see required and a few others. In its parent class, base type, we see a few more, like label and attr. We can use these to customize the label or add a class to the field form right inside the form class. When we refresh, we see these options working for us. HTML5 validation is nice, but not enough. We still need server-side validation. Also, you can't really customize how HTML5 validation looks or its messages easily. And finally, Symfony automatically defaults all fields to have the required attribute, which is kind of annoying. I recommend avoiding HTML5 validation entirely. To disable it, just add a noValidate attribute to your form tag. Refresh the form and try to submit empty. We get a huge error from the database, which proves that HTML5 validation is off. Now, let's add some server-side validation. In Symfony, validation is done a little bit differently. Instead of validating the submitted form data itself, validation is applied to the user object. Start by heading to the validation chapter of the documentation. Click on the Annotations tab of the code example and copy the use statement. Paste this into your user class. Whenever you add annotations, you need a use statement. Adding a validation constraint is easy. To make the username field required, add @assert/notBlank above the property. Try it out. When we submit the form blank, we see the validation error above the field. It looks terrible, but we'll work on that later. To customize the message, add the message option. Refresh to see the new error. All of this magic happens automatically when we call handle request in our controller. This takes the submitted values, pushes them into the user object, and then applies validation. Let's keep going. We can use the length constraint to make sure the username is at least 3 characters long. For the email property, use notBlank and email to guarantee that it's a valid email address. For plain password, we can use the notBlank constraint and the regex constraint to guarantee a strong password. Let's try this out by filling out the form in different ways. All the errors show up. They're just really ugly. Symfony comes packed with a lot of other constraints you can use. Check them out in the reference section of the documentation. You can see the length constraint we just used and all the options for it. Cool! Check out the unique entity constraint. This is useful if you need to make sure a value stays unique in the database. We need to make sure that nobody signs up using an existing username or email address, so this is perfect. The unique entity constraint is special because, unlike the others, this one requires a different use statement. Copy it into your user class. Also, @uniqueEntity goes above the class, not above a property. It takes two options: the field that should be unique, followed by a message. Add a constraint for both the username and the email. If we try to register with an existing username or email, we see the error. Before we move on, I want to show you one more useful constraint. Callback. This constraint is awesome because it lets you create a method inside your class that's called during validation. You can apply whatever logic you need to figure out if the object is valid. You can even place the errors on exactly which field you want. If you have a more difficult validation problem, this might be exactly what you need. We won't show you it here, but check it out. After registration, let's make the new user feel loved by giving them a big happy success message. Symfony has a feature called flash messages, which is perfect for this. A flash is a message that we set to the session, but that disappears after we access it exactly one time. After registration, grab the session object from the request and get an object called a flashbag. Set a message on it using add. That's it. Now, if a flash message exists, we just need to print it on the page. Let's do that in base.html.twig. The session object is available via app.session. Use it to check out if we have any success flash messages. If we do, let's print the message inside a styled container. You'll typically only have one message at a time, but the flashbag is flexible enough to store any number. The success key is just something I made up. With this setup, whenever we need to show a happy message, we just need to set a flash message and it'll show up here. Let's test it out. We register, the flash message is set, and then it's displayed after the redirect. Nice! After registration, let's log the user in automatically. Create a private function called authenticateUser inside register controller. Normally, authentication happens automatically, but we can also trigger it manually. This code might look strange, and I don't want you to worry about it too much. The basic idea is that we create a token which holds details about the user, and then pass this into Symfony's security system. Call this method right after registration. Try it out. After registration, we're redirected back to the home page. But if you check the Web Debug toolbar, you'll see that we're also authenticated as Padme. Sweet! Our site is looking so cool. But how can we be sure we haven't broken anything along the way? Right now, we can't. Let's avoid the future angry phone calls from clients by adding some tests. There are two main types: unit tests and functional tests. Unit tests test individual PHP classes. We'll save that topic for another screencast. Functional tests are more like a browser that surfs to pages on your site, fills out forms, and checks for specific things. When we generated the event bundle in the last screencast, it created 2 stub functional tests for us. How nice! Create a test controller directory and user bundle. Copy one of the test files and rename it to Register Controller Test. Rename the method to Test Register. The idea is that each controller, like Register Controller, will have its own test class, like Register Controller Test. Then each action method, like Register Action, will have its own test method, like Test Register. There's no technical reason you need to organize things like this. The only rule is that you need to start each method with the word test. That client variable is like a browser that we can use to surf to pages on our site. Start small by testing that the register page returns a 200 status code and that the word register appears somewhere. The assert equals and assert contains methods come from PHP-unit, the library that will actually run the test. To run the test, we need PHP-unit, the de facto tool for testing. You can install it globally or locally in this project via Composer. For the global option, check out their docs. Let's use Composer's require command and search for PHP-unit. Choose the PHP-unit result. For a version, I'll go to packages.org and find the library. Right now, it looks like the latest version is 4.1.3. I'll use the constraint ~4.1, which basically means 4.1 or higher. This added PHP-unit to the require key in composer.json. And it ran the update command in the background to download it. We now have a bin/PHP-unit executable, so let's use it. Pass it a -c app option. This tells PHP-unit to look for a configuration file in the app directory. And hey, there's a phpunit.xml.dist file there all ready for it to read. This tells PHP-unit how to bootstrap and where to find our tests. But we see a few errors. If you look closely, you'll see that it's executing the 2 test files that were generated automatically in Event Bundle. Get rid of these troublemakers and try again. Green! PHP-unit runs our test, where we make a request to /register and check the status code and look for the word register. To see what a failed test looks like, change the test to check for akbar instead of register and rerun it. It doesn't find it, but it does print out the page's content, which we could use to debug. It's a trap! Change the test back to look for register. When we call the request function, it returns a crawler object, which works a lot like the jQuery object in JavaScript. For example, to find the value of the username field, we can search by its ID and use the attr function. It should be equal to Leah. Rerun the test to see the result. One of the most common things you'll want to do in a test is fill out a form. Start by using the crawler to select our Submit button and get a form object. Notice that we're selecting it by the actual text that shows up in the button, though you can also use the ID or name attributes. In the browser, if we submit the form blank, we should see the form again with some errors. We can simulate this by calling submit on the client and passing it the form variable. Both request and submit turn a crawler object that represents the DOM after making that request. Be sure to always get a new crawler variable each time you call one of these methods. let's test that the status code of the error page is 200 and that we at least see an error. Run the test again. Beautiful! Let's submit the form again, but this time with some data. Use Select button to get another form object. Now, give each field some data. This is done by treating the form like an array and putting data in each field. These names come right from the HTML source code, so check there to see what they look like. Now, when we submit, the response we get back should be a redirect. We can check that by calling the isRedirect method on the response. Next, use the followRedirect method to tell the client to follow the redirect like a standard browser. Finally, let's make sure that our success flash message shows up after the redirect. Run the tests. Success! We now have proof that we can visit the registration form and fill it out with and without errors. If we accidentally break that later, our test will tell us. When we try running the test again, it fails. What the heck? If we did a little debugging, we'd see that it fails the second time because the username and email in the test are already taken. So instead of success, we see a validation error. This is a very important detail about testing. Before running any test, we need to make sure the database is in a predictable state. Our test will pass unless there happens to already be a user 5 in the database. To fix this, let's empty the user table before running the test. Start by grabbing the container object, which is stored statically on the parent test class. Now grab the Doctrine Entity Manager by getting the Doctrine service and calling getManager. If you're not comfortable with what I just did, don't worry. I'll demystify this in a moment. Once we have the Entity Manager, we can get the user repository. Build a query from the repository that deletes all of the users. Rerun the test again to see that everything passes. Now this is a good-looking test. Notice that we're not testing for every tiny detail. That would be a ton of work, and functional tests aren't meant to replace us as developers from making sure things work when we build them. Instead, we just want to see that the form can be submitted successfully and unsuccessfully. The important thing is that if we break something major later, our test will let us know. When we run our tests, it's emptying the same user table we're using for development. That's kind of annoying. Instead, let's use two different databases, one for development and one that's used only by the tests. Open up the main config.yaml file and find the Doctrine database configuration. Copy and paste it into the config_test.yaml file. but remove everything except for the DB name option. Now add an underscore test to the end of it. This little trick takes advantage of how Symfony environments work. The test environment uses all of the normal Doctrine configuration, except that it overrides this one option. Don't forget to set up the new database by running Doctrine database create. Pass an extra --env equals test option so that the command runs in the test environment. And now use the same idea to insert the schema. You can now rerun the test knowing that our main database isn't being affected. As cool as this is, in reality, we use a tool called bhat instead of Symfony's built-in functional testing tools. And you're in luck, because everything you just learned translates to bhat. Check out our tutorial on this to take your functional testing into space. Do this, or risk an angry phone call from Darth Vader when the super laser doesn't fire because you added a new espresso machine in the break room. In our test, we needed Doctrine's entity manager, and to get it, we used Symfony's container. Remember from the first episode in this series that the container is basically just a big array filled with useful objects. To get a list of all of the objects in the container, run the container debug console command. One of these objects is called Doctrine, which is an instance of a class called registry. So when we say container get Doctrine, we're getting this object. Find the shortcut in your editor that can open files by typing in their file name. Use this to find and open registry.php. Inside, you'll see the getManager method being used, which actually lives on its parent class. So how does this compare with how we normally get the entity manager in a controller? Open up Register Controller. That's right, in a controller we always say this getDoctrine getManager. The getDoctrine method lives inside Symfony's controller class, which we're extending. Let's open up that class to see what this method does. Aha! The getDoctrine method is just a shortcut to get the service object called Doctrine from the container. This means that no matter where we are, the process to get the entity manager is always the same. Get the container, get the Doctrine service, then call getManager on it. My big point is that if you have the container, then you can get any object in order to do any work you need to. The only tricky part is knowing what the name of the service object is and what methods you can call on it. Using the App Console Container Debug task can help. The site is looking sweet. And now with most of the work behind us, let's relax a little and have some fun. In this last part, we'll check out some cool things related to forms and security. Remember when we disabled HTML5 validation earlier? Let's add it back temporarily. Remove the noValidate attribute so that it works again. Now open the user class. Let's do a little experimenting. Let's pretend that the email field isn't required. Remove the not blank constraint from it and set a nullable equals true option in the Doctrine metadata. Don't worry about updating your schema. This change is just temporary. Now open up Register Form Type and remove the required option, which determines whether or not the HTML5 required attribute should be rendered. When we surf to the registration page and try to submit, HTML5 validation stops us. And just like before, the email field has the required attribute on it. We saw earlier that we can fix the problem by setting the required option to false for that field. But shouldn't the form be able to see that the email field isn't required in user and set the option to false for us? Actually, it can. The feature is called field guessing, and it works like this. Set the second argument of add for the email field to null. This might seem a little crazy because this argument normally tells Symfony what type of field this is. Will it be able to figure out how to render this field? Refresh the page and inspect email. There are a bunch of awesome things happening. First, notice that the field is still type equals email. That's being guessed based on the fact that there is an email constraint on the property. Remove the email constraint and refresh. Symfony doesn't know anything about the field now, so it just defaults to the text type. But now notice that the required attribute is gone. In addition to guessing the field type, certain options are also guessed, like the required option. Let's play with this. Add back the not blank constraint and refresh. Not surprisingly, the required attribute is back. Next, remove not blank, but also make the field not null. Yep, the required attribute is still there. The form system guesses that the field is required based on the fact that it's required in the database. Even the max length attribute that's being rendered comes from the length of the field in the database. So here's the deal. If you leave the second argument empty when creating a field, Symfony will try to guess the field type and some options, like required, max length, and pattern. Field guessing isn't always perfect, but I tend to try it at first and explicitly set things that aren't guessed correctly. Let's put our two validation constraints back and add the email type option in the form and refresh. If you were watching closely, the max length attribute disappeared. This is a gotcha with guessing. As soon as you pass in the type argument, none of the options like required or max length are guessed anymore. In other words, if you don't let Symfony guess the field type, it won't guess any of the other options either. Let's change gears and mention a few more things about security. Earlier, we saw how you could enforce security in two different ways. The access control method is the easiest. But we can always enforce things manually in the controller. In both cases, we're checking whether or not a user has a specific role. If they do, they get access. If they don't, they'll see the login page or the access denied screen. In our example, we showed a pretty basic system with just role user and role admin. If you need another role, just start using it. For example, if only some users are able to create events, we can protect event creation with a new role. To show this, let's make the role that's passed to enforce user security configurable. And then only let a user create an event if they have some role event create role. The only rule when creating a role is that it must start with role underscore. If it doesn't, you won't get an error, but security won't be enforced. Try it out by logging in as an admin. But first, reload the fixtures, since our users were deleted earlier when running our functional test. Now try to create an event. No access! Our admin user has role user and role admin, but not role event create. If we want to give all administrators the ability to create events, we can take advantage of role hierarchy, which we can see in security.yaml. Add role event create to role admin and refresh again. We are in! Now, let's schedule that Wookiee wind down. Keep these two tips in mind when using roles. 1. Protect the actual parts of your application using feature-specific roles, not user-specific roles. This means your role should describe the features they give you access to, like role event create, and not the type of user that should have access, like role admin. Use the role hierarchy section to manage which types of users have which roles. For example, you might decide that role user should have role blog create and role event create, which you set up here. Assign your actual users these user-specific roles, like role user or role marketing. By following these tips, you'll be able to easily control the exact areas of your site that different users have access to. What's that role allowed to switch all about in security.yaml? Symfony gives you the ability to actually change the user you're logged in as. Ever have a client complaint you couldn't replicate? No, us either. But if you do have one, you can log in as them without knowing their password. Now that is a Jedi mind trick. To activate this feature, add the switch user key to your firewall. To use it, just add a _switch_user equals query parameter to any page with the username you want to change it to. When we try it initially, we get the access denied screen. Our user needs role allowed to switch to be able to do this. Add it to the role admin hierarchy to get it. When we refresh, you'll see that our username in the Web Debug toolbar has changed to Darth. So cool! To switch back, use the _exit key. Next, look again at access control. Right now, our entire site is open to the public, except for the specific pages that we're locking down in our controller. But what if almost every page on our site required login? Is there a nice way to enforce this? Add a new access control that matches all requests and requires role user. Now every page is locked down. Log out and try it. A redirect loop. We've got too much security. When we go to any page, we don't have access and are redirected to /login. Of course, we don't have access to /login either, so we're redirected to /login. Do you see the problem? To fix this, add a new access control entry above this for any page starting with /login. For the role, type is authenticated anonymously. Refresh again. It works! We're missing our styles, but we'll fix that next. The access control entries match from top to bottom and stop after the first match. When we go to /login, the first control is matched and executed. By saying is authenticated anonymously, we're whitelisting this URL pattern, because every user, even anonymous users, have this role. Run the router debug task to see a few other URLs that we should whitelist. These include some URLs that load our CSS files, as well as the Web Debug toolbar and profiler during development. We also need to let anonymous users get to the registration page. We haven't talked about aesthetic much yet, but by blocking its URLs, we're blocking our style sheets. With these entries in place, we're in good shape. Now that we're logged in, how can we get access to the user object? Open up the homepage template. In Twig, we can access the user object by calling app.user. Let's use it to print out the username. From a controller, it's just as easy. Go to the controller function for the homepage and grab an object called the security context. Then call getToken and getUser. Actually, since this is a bit long, the Symfony base controller gives us a shortcut method called getUser. I showed you the longer option first so that you'll understand that there is a service called security.context, which is your key to getting the current user object. Remove this debug code before moving on. I want to leave you with just one more tip. We talked a bit about the Remember Me functionality, but we didn't actually see how to use it. Activate the feature by adding the remember_me entry to your firewall and giving it a secret random key. Next, open the login template and add a field named _remember_me. This works a bit like login does. As long as we have an _remember_me checkbox and it's checked, Symfony will take care of everything automatically. Try it out. After logging in, we now have a Remember Me cookie. let's clear our session cookie to make sure it's working. When I refresh, my session is gone, but I'm still logged in. Nice. Click anywhere on the Web Debug toolbar to get the profiler. Next, click the Logs tab. If you look closely, you can even see some logs for the Remember Me login process. Okay, gang, that's all for now. I hope I'll see you in future KMP screencasts. And remember to check out kmpbundles.com if you're curious about all the open source bundles that you can bring into your app. See you next time!